Hi, this is an overview into some work that I've been doing on bounded region analysis. Essentially, if you've got a network of lines, it's just some kind of algorithm or process that you can instruct the computer to go through in order to detect particular regions formed by individual lines. And in doing this work, I've been using a map of Jamaica, which is split into 14 different parishes. But I'm going to start off by giving some kind of overview of why I was interested in doing this and how far I've gotten. Okay, so the work started off by first of all trying to understand is there any correlation between where a school is located and the performance of the school in the ability of the students, particularly high school students, in their reading and writing ability. So here we've got a map of Jamaica, and all those purple markers are locations of schools, and these thick white lines are parish boundaries. So there are 14 in Jamaica. And here I've selected two particular parishes. The one on the right hand side is Manchester, and the one on the left hand side is St. Elizabeth. And inside that we've got these individual lines running across the entire parish region. And what these lines indicate, if I show background to it, what these lines correspond to are regions of particular poverty level. So areas of high poverty are in dark brown, and lighter poverty regions are in lighter colors. And the whole thrust of this work was to try and understand if, by having these individual lines, can I somehow write an algorithm that can look at the map and join the different lines in order to make specific bounded regions. So for example, you've got this school here, Magotty High School, is right in the middle of quite a sort of a high deprivation area. So my focus was on whether or not I could write an algorithm that could join this red line, blue line, and all these intermediate lines in order to identify this brown area. So if we just deselect this poverty map and we zoom in, we can see that these bounded regions are they cover quite a large distance on the ground. So you can see, those are residential areas, and this is one particular line. And over the whole country map, you have a network of these lines, which, when they join together, form bounded regions. So originally, this came from some analysis that I and some colleagues did, trying to understand whether the reading and writing ability of boys and girls was influenced by different factors. So here we've got a chart of a particular female high school. I think this might be in Trinidad and Tobago, and you can see on the y-axis you've got the number of students, and on the horizontal axis you've got the grade type, with the lower grades increasing the further right you go. And you can see that a majority of these girls have got grades in the highest level. And in this tab, this is for a boys' school. Again, I think this is in Trinidad. And you see there's a wider spread in the grade distribution. So again, number of students on the vertical axis, and the grade type, with the lowest grade increasing towards the right. So what would happen if these particular grades and schools were plotted on a map, and we could see whether or not where the school was located had some kind of impact on the type of performance that we were observing? So if we reselect base map, and we select on a particular school, right? This is Lacovia High School. We click on it, it tells us it's 49% males and the number of students. This particular map doesn't show the actual performance, but we wanted to know if this region of specific poverty level, if it might have any impact on the performance. And furthermore, what would happen? What would happen if these regions started to morph and change, either expand or shrink, as happens with human factors like poverty and wealth? So, could we somehow write some kind of algorithm or some kind of process that would allow us to identify these bounded regions, with the hope that in the future we might be able to automate their expansion and contraction, and therefore monitor what impact that might have on the performance of the school? Right. So at the moment, this all this data is inside Google Earth, and it's static. In order to do the analysis, this is now the map analysis, which is aside from investigating the particular academic performance of the schools. This is trying to, if you like, write the program that automates the identification of bounded regions, and then tries to monitor whether or not they can expand and contract and still have some idea of where a particular school lies in that region. So taking all that data and exporting it into MATLAB, which is what we've been using for analysis, we get this type of map. So this is one parish, Saint Elizabeth, and it corresponds to this particular parish, this particular map section. So taking that data, we put it in MATLAB. It looks like this, and this is just a 2D map of those individual lines that we were observing. And as we said, there's 14 different parishes in Jamaica. This is one. This is St. James. This is Westmoreland, and this is Manchester.